Hello and welcome to this video. We are going to learn about geometric series, how to get the value of the next number or any nth number in a geometric series. So let's say we have a geometric series 2, 4, 8, 16 and so on. So I want you to first of all pause the video and try to work out the next two numbers in this geometric series. So in a geometric series, the ratio between any two consecutive numbers is common. So the ratio between 2 and 4 is the same case between the ratio between 4 and 8 and so on. So 4 divided by 2 is the same as 8 divided by 4. It's the same as 16 divided by 4, not by 4, sorry, but by 8. I'm sorry for that, and so on. So to find the value of x and the value of y, we need to use this ratio, which is 16 by 2 is 2. So it's common for each case. So to get the value of x, we need to multiply 16 by 2, or rather x over 16 should give us 2. So to get the value of x, we need to multiply 2 by 16, which is 32. So the value of x is 32. And then the value of y will be given by y divided by 32 should give us 2. So y will be 2 times 32, which is equal to 64. So the value of y is 64. So what if now you are asked to find even the 50th term, the 30th term of this series? It would really be difficult to go multiplying by 2 till we get to the 50th term or to the 30th term. So this means that we have to come up with a general formula that we can use to find the value of any nth number in this particular series. So I want you to look at this. So let's call this first term of this series, let's call it A. So A is the first term of this series. And then this ratio that is common for each case, we can call it the common ratio. Let's call it R. So I want us to write each of these terms in terms of A and R. So I said the first term is A. So what about the second term? The second term will be found by multiplying the first term, that is A, by the common ratio, which is R. So 2 times 2 will give us 4. So to get to the third term, we need to multiply A by the common ratio and then by the common ratio once again. So it's 2 times 2 times 2. And then the fourth term is going to be A times R times R times R. And then to the fifth term, it will be A times R 4 times R times R. So this is AR. This is AR squared, or rather AR, we can also write it as AR to the power of 1. And then this one will be AR to power 3. And this one will be AR to power 4. So I want us to come up with a trend, or to identify the trend that is forming here. So let me use a different color. So to get to the second term, we need the power of R is 1. For the third term, the power of R is 2. For the fourth term, the power of R is 3. For the fifth term, the power of R is 4. So that means, following the same trend, the sixth term is going to be AR to power 5, since the trend is there such that the power of r is 1 less the nth term. So the 7th term is going to be ar to power 6. So that is the pattern or the trend that I wanted us to identify. So that means the 10th term is going to be ar to power 9. The 14th term is going to be ar to power 10. Okay? So from this we can come to the conclusion that to get any nth term where n stands for the position of that term, maybe the 14th term n is 14, the 10th term n is 10. So the value of the nth term is going to be ar to power n minus 1. So for the 50th term it's going to be ar to power 50 minus 1, which is 49. And this is a general formula that we use in evaluating the value of any nth term of a geometric sequence. So I want us to go back to the sequence that we had here, and I want you to use the formula that we have just come up with to evaluate the value of the 8th term, and the 9th term. Okay. So you can pause the video and try to work it out by yourself, and then you can confirm whether what you did is actually the correct thing. So the 8th term is going to be a, which is 2 times r, which is also 2 raised to power 8 minus 1. So 8 minus 1 is 7. So that will be 2 times 2 to power 7, which is, you can use your calculators, and it's going to be 128. So that will be 256. So that is the value of the 8th term. And then to get the 9th term, okay, let me clear up some space here. To get the 9th term, it's going to be 2, which is a, times r, which is also 2, raised to power 9 minus 1, which is 8. So that will be 2 times 2 to power 8, which is 256. And the 9th term is going to be 512. And that is how to find the value of any nth term of a geometric sequence.